Hello everybody. Objective of this video is number 1 is to demonstrate the integration of a generic function is equals to b minus a over 2. Once this is proven, we will make use of it, make some trigonometry changes, and found the integration, the second integration is equals to pi over 4. All this thing has to be done without calculator. First objective is to prove this generic integration of function f is equals to answer I, which is we will find out what is I later. But first step, replace u equals to a plus b minus x. Therefore, du equals to negative dx, or dx is negative du. So this is needed later. Meanwhile, for the lower limit a, when x equals to a, what is u? U will be a plus b minus a, which is equals to b. On the other hand, the upper limit, when x equals to b, so therefore u will be a plus b minus b, which is equal to a. So we now change the integration to u, function u. First of all, the integration, the limit shall change to b to a based on the calculation here and here. And then the function f will change to function a plus b minus u. This is function x, because x has been changed, become a from here. X has been changed to a plus b minus u. Same goes to the function f of the bottom, become f a plus b minus u. Lastly, the function a plus b minus x, which is referred to here, become just fu plus fu. Multiply dx. What is our dx? The dx is actually negative du. Okay, which is again, this is supposedly equals to I. Okay, I is the supposed answer for the both integration. Okay, now let's change the negative du, bring it in front and swap the b and a. We have an integration of a to b, function f a plus b minus u divided by function a plus b minus u plus function u multiply du equals to I. The negative has been cancelled after we swap the limit from a to b. So here is an interesting situation. The variable is u here, but because it's generic, you can replace any symbol. For example, you can replace to x. Yes, we can replace it to any variable name because it's generic. Okay, now we have two equations here. Equation of fx here. The second equation is the one we finally derived, eq2. So now, if we have a eq1 plus eq2, this is what we're going to have. So what is eq1? This is our eq1. Integrate a to b fx divided by fx plus fa plus b minus x dx plus the eq2. This is our eq2. Integrate also a to b, very different, f a plus b minus x divided by the bottom also actually the same, but the first and second term change, dx. So in the right hand side you have I in the eq2, and then you have I in eq1. So the total of the eq1 eq2 is 2I. Very good. But if you look at the two equations summed together, you are actually having integration of a to b dx. Why? Because these two sum together, the top and bottoms are exactly the same. So just become 1. Just become 1, which is equals to 2i. So what is integrate of 1 dx, which is x a to b equals to 2i. Finally, we have I equals to b minus a over 2, which means this answer is going to be useful to here equals to b minus a over 2, as well as here equals to b minus a over 2. Both EQ1 and EQ2s are equals to b minus a over 2. Okay. So once we have this equation, we're going to plug into our trigonometry equation, which is integrate cos power 3 x divided by cos power 3x plus sin power 3x dx from 0 to pi over 2. Now we need to do some modification. The sin power 3x. According to the trigonometry, sin x is actually equals to cos pi over 2 minus x. So here it becomes integrate 0 pi over 2. The top still the same, cos power 3x. The bottom, the first term still the same, cos power 3x. Plus the second term become cos power 3 0 plus pi over 2 minus x. Integrate over dx. So this format is identically the same to our EQ1 here. So the answer is b minus a over 2. What is our b minus a over here? Okay, b minus a over 2. The b is pi over 2. The a is 0 divided by 2. So the answer is pi over 4. And this is the answer. Thank you for watching my video. Do subscribe to my channel. I see you in the next video.